3.12, energy and heat capacity calculations. Of course, we've been talking about all these quantities with numbers and units, so you kind of had to think there was going to be some calculations here, right? So here they come. The equation that relates heat to amount of substance, temperature change, okay? Q equals mc delta T. Q is the amount of heat, usually in joules. M is going to be the mass of the substance, which would be measured in grams. C is the specific heat capacity in joules per gram per degree Celsius. And that's a weird looking unit. And that's something you look up in a table, or they may give you all the other information and have you solve for it. T is temperature. So delta T, you see an error in this. Delta T is the change in temperature, and delta is the Greek letter D, and it means change in. And when we do change in science, it's always the final minus the initial. Okay, so delta T is the final temperature minus the initial temperature. So let's do an example here. It's a really long example. This one's got lots of words and numbers in it, so it's going to be really fun, right? Yes, aliens don't wear hats. You find a copper penny, pre-1982, in the snow and pick it up. How much heat is absorbed by the penny as it warms from the temperature of the snow, minus 5 degrees Celsius, to the temperature of your body, 37 degrees Celsius? Assume the penny is pure copper and has a mass of 3.10 grams. You can find the heat capacity of copper in table 3.4 on page 74 in your textbook. Wow, right? It's a lot of numbers. But we can do this. Okay, we just have to figure out what all these numbers are. There might be some that we don't need. I'll just tell you off the bat, we don't need the year 1982. That's kind of in there for a reason. In 1982, they changed the composition of pennies. Now they have a zinc core with copper on the outside. And because it's two metals, it's not going to do the same thing as pure copper. Pennies before 1982 were pure copper, so that's why they even stuck that in there. So read the question all the way through. Read it out loud if you need to. And then kind of visualize. Oh, this one's easy to visualize. I find a penny in the snow, and it's going to be cold, right? I pick it up. The temperature of it is minus 5. I pick it up, and then what happens to the penny as it's in contact with my hand? It's going to warm up, right? It's going to warm up until it gets as warm as my hand, which is 37 degrees Celsius. What they're asking us is how much heat is absorbed by the penny when it does that. So this is going to be one of those Q equals mc delta T questions. So we need Q equals mc delta T. Well, the mass is fairly easy. The mass is 3.10. Mass equals 3.10 grams. Gram is a clue there. That's a unit of mass. What's the temperature change?
42 degrees Celsius.
Yeah, we're going to take these two temperatures and subtract them. Delta T equals the final temperature, 37.0, minus the initial. Oh, there's that subtracting a negative thing. Your calculator can handle it. 42 degrees Celsius. This equation has, I did not want to do that. Nice, I lost it all. Perfect. It's perfect.
Murphy's Law.
Yeah. Q equals mc delta T, just in case you didn't get it all the first time. M is 3.10 grams. Delta T is the final minus the initial, 37.0 minus 5, you gotta be careful with those negatives, equals 42 degrees Celsius. This equation has four variables, Q, M, C, and delta T. So to solve it, we have to have three of the values given, and they'll ask us for the fourth. And it could be any of them. This one's the easy kind, is asking us to find Q. So what are we missing here? We're missing C. We need to go look that up, right? 0.385? Thank you. So we look C up, 0.385, and the units are joules per gram degree Celsius. Let's see if this will work. Yes, good. Made the question disappear. So I have more room. Okay, so now we just need to plug these into our equation. Q equals, M is 3.10 grams, put the units in there. C is 0.385 joules per gram degree Celsius. And delta T was 42.0 degrees Celsius. Okay, so I identified the numbers. I had to do a little calculation to find what delta T was. And then I put all of them into the equation. And show your work, at least this equation that I just wrote down here. That is showing your work with the numbers plugged into the equation. So 3.1 times 0.385 times 42. The number comes out to be 50.127. And then let's look at the units. Grams cancel grams. And degrees Celsius cancel degrees Celsius, and I'm left with joules, which is good because joule is a unit of heat, and we're calculating heat. Now we have to look at the significant figures. Each of these numbers has how many significant figures? 3. 3.10, 0.385, 42.0. So our answer is going to have 3 significant figures. So we're going to call that 50.1 joules. And that's the amount of energy that gets transferred from your hand to a penny when you pick it up in the snow. I know that was just this burning question in your brain this morning. I just really need to know this, right? Any questions? So we're going to do a couple more examples. Here's another one. When 56 joules of heat are added to 11 grams of a liquid, its temperature rises from 10.4 degrees Celsius to 12.7 degrees Celsius. What is the heat capacity of the liquid? And this is the sort of process by which we measure heat capacities, is we measure the heat and the temperature and the mass, and then we can calculate it. So let's identify what these numbers are. So we have 56 joules. That's a measure of what? Heat. So that would be what letter in our equation?
Q.
Q. Q equals 56 joules. 11 grams, what's that?
Mass.
Mass. M equals 11 grams. Temperature rises. Okay, so it may be helpful to identify the final and the initial. The initial temperature is what it starts at. The initial temperature is 10.4. The final temperature is what it goes to, 12.7. And sometimes the temperature falls, and then Q ends up being negative, and that's okay. So delta T equals final minus initial, so 12.7 minus 10.4, which is what, 2.3? 2.3 degrees Celsius. So the equation that we learn is Q equals mc delta T. But we're trying to solve for C. We need to rearrange. So we're going to divide this side by m and delta T. And we're going to divide that side by m and delta T. The m's cancel, the delta T's cancel, I'm left with C on that side. C equals Q over m delta T. Ran out of room. I'll write small. So Q equals 56 joules over 11 grams times 2.3 degrees Celsius. How many significant figures should that have? 2. I'm going to write it over here. C equals 2.2. The units are joules per gram degrees Celsius. You see the box is real nice when you run out of space and things get a little messy because we can see all the answers right over there. Any questions? Bless
Sorry,
you.
another chemistry.
It's going to be on YouTube this afternoon, okay? And his sneeze.
Sorry, you two.
That's okay. Okay, here's another one. A fishing weight with a mass of 75 grams absorbs 146 calories of heat. If its initial temperature is 47 degrees Celsius, what is its final temperature? Okay, so we read through the whole question, and then we identify these numbers. So 75 grams is what?
The mass.
That's the mass. 146 calories is what?
Heat.
That's heat. Heat is Q. Don't ask me why. Okay, its initial temperature. So that's T initial is 47 degrees Celsius. And we're trying to find the final temperature. So we identified all the numbers we had, which are things that were given to start with. We identified what we're trying to find, the final temperature, and now we need to figure out how we're going to do that. Well, the equation that we have is Q equals mc delta T.
So we need to look up the heat capacity of lead.
We need C. We need the heat capacity of lead. Can somebody look that up for me?
Lead is 0.128.
C equals 0.128. 128, and the units on that?
Joules over grams.
Joules per gram degrees Celsius, right? Okay. So we have this equation. Now we know Q, M, and C. What we're going to do is we're going to find delta T, and then knowing what the initial is in a little separate problem, we can find the final temperature. So we need to rearrange this for delta T. So we're going to divide by M and C on that side, and we're going to divide by M and C on this side, so those guys cancel out. So delta T equals Q over MC. Now, does anybody anticipate a unit issue here?
So we have calories and joules. So
We have calories and we have joules, and so those aren't going to cancel out. So, yeah, this is going to become just a giant mess. So we need to convert 146 calories to joules. So down here, I'm going to say Q equals 146 calories. We need to convert that to joules. The relationship is 4.184 joules per 1 calorie. So 146 times 4.184 equals, calculator says 610.864 joules. The calories canceled out. How many significant figures does that number have? 3, because 146 has 3. So what I'm going to do is I'm going to underline there, but I'm going to use that whole number in my equation because we haven't gotten to the final answer yet, and we don't want to have any rounding errors. So Q equals 610.864 joules divided by M, which is 75 grams, and divided by C, 0.128 joules per gram degrees Celsius. Our units get kind of weird looking here, don't they? Joules cancel. These grams, we have numerator and denominator in the denominator. And what we're left with is 1 over C, degree C, which is degree C. So we're going to take that 610.864 divided by 75, divided by 0.128. And we're going to get delta T equals 63.6316 repeating degrees Celsius. Anybody else get that number? How many significant figures should that number have?
3.
Well, our numerator had 3. The 0.128 had 3, but 75 has only 2, right? So this should only have 2 significant figures. 2 fingers. 2 fingers. So how do we find, that's our delta T. How do we find the final temperature? Yeah, it's this minus the initial temperature. So the final temperature, that's not final temperature. The final temperature is going to equal the change in temperature. Final minus initial, so it's the change plus the initial temperature. Because we had delta T equals T final minus T initial. So we have to add Ti to both sides. So we take 63.6, I'm just going to round it off there, add it to our initial temperature, which was 47. 63.6 blah 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 plus 47 gives us 110.6, but we're going to just round it there, and so 111 degrees Celsius. Wasn't that fun? Oh yeah, barrel of monkeys, right? Any questions? End of the chapter. Hooray. These Chapter in review slides at the end are there for your personal enjoyment to help you understand what were the most important points of the chapter. So those are just for you to enjoy.